All right, today we are continuing section 1.5, building on what we learned in class about transformations of functions. And I posted a handout with a few graphs on Blackboard that you need to reference for this video. The first graph is this kind of weird looking disjointed ice cream cone graph, and this is f of x. And they've asked us to graph f of x plus 2 plus 3. So we don't have the formula for f of x, just its graph. All right, so let's look at the two transformations you have going on in this function. We've got plus 2 and we've got a plus 3. All right, so the plus 2 is inside the parentheses. This is the same thing as like being underneath the radical or inside the absolute value bars. This is an inside transformation, so it's going to be a horizontal shift. The plus 3 is outside, so it's going to be a vertical shift. Okay, so with the plus 3 on the outside, we know when we add, it's going to go up. So we're going to shift to this graph up 3. And then with the plus 2 on the inside, we know the horizontal shift rule goes kind of backwards of our intuition. Plus 2 means that we're going to go to the left 2. All right, so you can do these two transformations in one step. So it doesn't matter if you go to the left 2 and then up 3, or if you go up 3 and then to the left 2. You're going to land at the same spot. All right, so I'm going to do both of these at the same time. I'm going to grab the point that is at 0, 0, the origin, and I'm going to move it to the left 2 and then up 3. Okay, so if I go to the left 2, that would land me here at negative 2 comma 0, but then I'm going to also move it up 3. So then I'm going to go 1, 2, 3. So that leftmost point of that semicircle is going to be there at negative 2 comma 3. So then the top of that dome, I'm going to take that one and move it to the left 2 and then up 3. So that's going to land me at negative 1 comma 4. Then that x-intercept, I'm going to move that to the left 2. That would put me at the origin, and then up 3 would put me at 0 comma 3. So you can already see where that circular part of the graph is going to be. So now let's take care of the v. So the bottom of the v, I'm going to take that point and move it to the left 2. That would put me there. And then up 3, 1, 2, 3. So the bottom of the v is going to be at the old top of the circle. And then the end of the graph over there on the right, we're going to move that to the left 2. And then from there, we move up 3. So I'm just kind of picking landmarks on the graph to kind of shift around the way that I need to, and then we'll fill in the overall shape at the end. So I'm going to fill in with a semicircle over here on the left. You know, just do your best approximation thereof, and then a V shape over on the right. And that's going to be our final answer, f of x plus 2 plus 3. All right, so let's stick with this graph and do a couple more transformations. All right, so this one asks us to graph negative f of x minus 2. Okay, so we have minus 2. That's kind of hanging out on the outside. That's the same as the plus 3 in the last one. So it's subtraction instead of addition, but it's on the outside. So this means it's going to be a vertical shift. This one's going to move it down 2. Okay, but the negative on the outside, that's actually multiplication, right? Negative 1 times f of x. So we saw that negative 1 times a function means that it's going to be a flip. Okay, again, I'm multiplying on the outside of the function, not inside on the parentheses with the x. So outside means we're doing something vertical. So this is going to be a vertical reflection. So we're going to reflect or flip vertically. Okay, or you can think of that as reflecting over the x-axis or using the x-axis like a hinge to rotate the graph. All right, so this one, it actually matters what order we do these transformations in. If you remember our order of operations, you can think of the multiplication and division as a block and the addition and subtraction as a block. Okay, so within those little blocks, it doesn't matter if you do addition and subtraction or subtraction then addition, you're going to get the same graph. But if you have a multiplication division transformation and an addition subtraction one, you need to make sure to do those in order of operations. Okay, so we have our reflection vertically, which is done by multiplication by negative 1, and down 2 is done by subtraction, which puts us in that block. So we need to do our reflection vertically first, and then we can move it down 2. Okay, so everything that's above the x-axis is going to come below. Everything that's below is going to get flipped up above. So I'm going to do this in my blue pen. All right, so I'm going to take that semicircle and it's going to flip down below the x-axis. Now, anything that's on the x-axis is going to stay on the x-axis. Okay, so think about this flip as like grabbing the x-axis and rotating it 180 degrees to flip everything upside down. Anything that's on the axis as you rotate is still going to be stuck to the axis. All right, so I'm going to be flipping that circle down below, and I'm going to be taking that v down below and flipping it up above. Okay, so the point down here is at -2. That's going to come up to +2. And then, of course, 4, 0 is on the x-axis. All right, so this is just our first step, but let's go ahead and fill this in. Okay, so just the, looks like we made a circle and a diamond there, all right, but the blue part is actually the graph that we're talking about, and that would be the final answer if they had asked us just to graph f of -x. All right, but now they want us to pick that blue graph up and move it down 2 tick marks. All right, so I'm gonna take the point, let's go left to right, 0, 0, I'm gonna move that one down 2. The bottom of the circle moves down 2. The middle of the graph moves down 2. The peak up at that point, that's going to move down 2. That's going to be on the x-axis now. And then the rightmost point down 2, and they're at 4, -2. Right, so we're just picking up landmarks and then filling in the shape. So fill in our upside down semicircle part. And then the point. All right, and that's our final answer. This is our negative f of x minus 2. Let's try one more with this graph. All right, so this one wants us to graph 2 times f of -x. And again, we have 2 transformations going on. So I've got the 2 on the outside, and I've got the negative on the inside. Those are both being accomplished by multiplication, so they're in that block together. So this one is, again, not going to matter what order we do these transformations in. But let's write down what they are. Let's see, so the negative x multiplying by a -1 causes a reflection. This time the negative is inside those parentheses of the function. So this is an inside transformation, which means horizontal. So this is going to be another flip, another reflection, just over the y-axis. It's going to be a horizontal reflection. All right, and then the 2 on the outside, that's multiplication by 2, not adding 2. So this is going to be doubling things. It's doubling y coordinates. So that's going to be one of our vertical stretches. All right, so again, it doesn't matter which one we do first, right? So I'm going to do the stretch first since I got my red pen already turned on. All right, so I'm going to multiply all of the y coordinates of this entire function by 2. All right, so anything that's on the x-axis has a y-coordinate of 0, and 2 times nothing is nothing, right? 2 times 0 is 0. So all of those x-intercepts are going to stay put when we stretch things out. The rest of the points, whatever is positive is going to become more positive, whatever is negative is going to become more negative. All right, so the top of this circle has a y-coordinate of 1. I'm going to double that to 2. The bottom of the point has a y-coordinate of -2. I'm going to multiply that by 2 to get -4. Okay, so this is just going to look like a stretched out version of itself. So instead of a semicircle, we have a semi-ellipse. And then still a V shape over here, just a really skinny V shape because it's been stretched out. All right, so then we're going to take our red graph, which would be the graph of 2 times f of x, and we're going to reflect that horizontally. So everything that's over here on the right, I'm going to move over to the left. All right, so again, anything that's on the y-axis, which is that leftmost point, when we rotate that y-axis to flip it around, it's going to stay put. So that point hasn't moved again. The top of the ellipse is at a y-coordinate, excuse me, an x-coordinate of 1. It's going to move over here to -1. My middle point at 2, 0 is going to move over to -2, 0. And then the V shape is going to move over to x-coordinates of -3. And then the intercept at -4. Let's fill in that semi-ellipse shape. And then the V shape. And that'll be our final answer. So 2 times f of -x.